The first case to consider will be to perform a single left rotation to restore the balance for the tree after a single insertion. Let's see how we can do that. Okay. This will be the general picture about how to perform a left rotation. The reason that it is left is you can see this is before the rotation. We are trying to rotate on the middle node B, and we're trying to promote B over here in this way. You can see my mouse cursor over here. And I'm gonna illustrate this to you again later. So it's a left rotation. And once we have done that, this will be the balance tree. It's a very similar diagram as I showed to you earlier when I introduced to you about the rotation, but that one was actually a symmetric direction, the right rotation, but the idea would be similar. And of course, we always have to ask ourselves, is the BST property maintained? And the way to judge it will be to see the in-order traversals between the before and after rotation should be the same. And that's something that we can take a look as well. So this will be just the abstract explanation. All right, so let's now talk about the first example for case number 1. So we want to insert the following sequence of nodes with the keys into an empty BST, and then we're going to do the series of discussion on the paper. Let's take a look. Okay. So what we'll do is we're going to insert in the following order, starting from the empty BST, which this exercise we have done that in the beginning of the lecture already. So let's do that. So what we'll do is 44. So 44 is going to be inserted as the root, and then 17 over here, 78 over here, and also 32. 32 will be here, right? If you have any doubts, you can reach out to me. And then 50 should be over here, I believe. And then 88, which will be over here. And also, finally, 95, which will be over here. And just to be consistent with our convention, all the nodes with the key value are the internal nodes, and we also got the dummy external nodes as well. Just don't forget. So that means this one over here will be external over here. And this one over here also got 2 external nodes over here. And this one over here also got 2 external over here. And this one here got 1 external node over here. And this one here also got 2 external nodes. You can think about this will be part A. This is how we start with the tree. Is this tree balanced? That's a very important question to ask. Is this balanced? And to really see that, we got to annotate the heights for every node. So we start with the external as we did earlier. So it's going to be 0, 0, 0, 0, 0, 0, 0, 0 for all the external, right? And let's start with the internal. What about the height for this node over here? Maximum of 0 will be 0 plus 1. That will be 1. What about this node here? 0 and 1. Maximum will be 1 plus 1. That will be 2. And what about this node over here? 0, 0, and then plus 1. That will be 1, right? And what about this node here? 0, 0, and then plus 1. That will be 1 over here. What about this node? This node is going to be, the heights will be, for child nodes will be 0 and 1. Maximum will be 1, so the height should be 2. What about this node over here? 1 and 2. 1 and 2. Maximum will be 2, so that will be 3. And then, what about the heights for the root node? The maximum of 2 and 3 is 3 plus 1, we got 4, right? And of course, if you try to compare for every internal nodes, the heights for its child nodes should be different in by no more than 1. Right? You can see, for example, for this node over here, it is balanced because 0 and 0, the difference is 0. So let me just do that quickly, quick check together with you. 0, 0, difference no more than 1. 0, 0 and 1, that's also fine. 0 and 0, 0 and 0 is fine. 0 and 1 is fine. 1 and 2 is okay. 2 and 3 is actually okay, right? So that's the kind of the exercise we did earlier, so we don't need to waste too much time. So is it balanced or not after constructing the tree? Yes, check. And for part B, we're actually going to insert a new node into the tree with 100, right? So what we're going to do is we're going to say we're now going to move to the second part, in which case we're going to insert 100. And I'm just going to make a copy of this tree over here. We can definitely reuse it, but we may have to actually update the heights if necessary. Okay, let me paste it over here. Right, so this will be after the insertion. What do we want to insert? We want to insert 100 over here. Let's see where 100 should go. Larger than 44, so we should go here. Larger than 78, so we should really go here. Larger than 88, so we should really go here. Larger than 95, so we should go here. So this will be the external nodes returned by the searching process, right? The search subroutine. So what's going to happen is we have to convert this node over here to be an internal node. So that will be 100. After we put 100 over here, of course, you got 2 external nodes over here. Okay, let's now update the heights. 0 and 0, and for heights for 100 node, it should be maximum of 0 and 0 plus 1. That'll be just 1. However, we have to update the heights from now on along the ancestor path. What about the heights for 95 over here? Maximum of 0 and 1 should be 1. 1 plus 1 should be 2 over here, right? And also, what about this node over here? Node 88. 0 and 2. Maximum is 2 plus 1, so that should be 3 over here. What about the node over here, 78? So you can see maximum of 1 and 3 is 3. 3 plus 1 is actually 4. And what about the next node? Is it what will be its heights? So maximum of 2 and 4 is actually 4. 4 plus 1 is going to be 5. Right? You can see along the ancestor path. Let me just highlight to you the ancestor path. You can see 100 is the node we have added, and this is the ancestor path over here. Along the ancestor path, let me just make a note over here. That's the ancestor path. Along the ancestor path, we had to update these nodes over here for their heights. And you can see starting from this point already, you can see between the 2 child nodes, their heights 0 and 2. That's really the earliest part. The first node that actually becomes unbalanced. Right? Let me identify that first for you. You can see for between this and this is actually okay, 0 and 1. But between this and this is not good. Okay, so this is the part that actually we can make a note over here. The difference is actually 2. So what conclusion can we draw? The fact that these 2 child nodes have their heights 0 and 2, the difference is more than 1. So that means the node over here is unbalanced. So this is the very first node we have encountered in the ancestor path for the new node being added over here that's become unbalanced. It's very important to see this mini conclusion. Let me write it down right away. So we have to identify this very first node over here. So this is the first node. Okay, let's now write it down over here. So this is the first node. The first node becoming unbalanced. And accordingly, we're going to identify its child and also grandchild as we said in the general principle. So this node over here will be what we call A. Okay, and then its child node over here along the ancestor path will be 95 over here. This will be the node B. And then this node over here will be C. Okay, over here, that will be C. We got A, B, and C. And because they slant the same way, so only a single rotation will be needed. And to be more precise, because they slant to the right, what kind of rotation should we do? It should be the opposite direction. If the unbalanced nodes are slanted to the right, in that case, we do a left rotation to fix them. That's kind of intuitive. Right, so let's now, so we say A, B, and C slant to the right. So that means a left rotation needed on the middle nodes, on the middle node B. This will be very important to also realize as well, right? And just highlight it over here. So what we want to do is we want to do a left rotation on the middle nodes B. Okay, let's now see how we can do it. So what I will do is, let's see one more transformation what's going to happen is we're going to change this to over here, a left rotation on the middle node B. Well, let's see how we can do that. What I would do is, let me just copy the original tree, right? I really want to show you how you can do it from scratch, so you will be able to draw that by yourself as well. Okay, and so far we got two parts done already, right? Part A and also part B, right? Just don't forget, part A before the insertion, part B after the insertion, and part C will be after the rotation. So I'm gonna put part C over here, so that will be the final part that you want to focus more. Right, let's see how we can do that. Let me paste the tree over here, right? That's good, just enough space. Okay, let me just put back the node that we actually inserted. Let me just do that quickly. Right, so I'm going to pull back that node I inserted, which was 100. And with the two external nodes over here, okay, let me also update the balance very quickly, right? Only along the ancestor path that I need to update. Okay, let me just put in red 0, 0, 1, and this part is 2, and then 3, and then 4, and then 5, right? Now, how do we do a left rotation? Let's now identify again A, B, and C. And we said before, this will be A, and this will be B, and this will be C. And if you refer back to the diagram we saw on the slides over here, that's exactly the A, B, and C over here. We also got T1, T2, T3, and T4. Let's identify them as well. You can think about this part over here is T1. This part over here is T2. And this part over here is T3. And this part over here is T4. Right? So let me just put back in the original diagram over here. So think about this part over here is T1. This part over here is T2. And this part over here is T3. And this part over here is T4. These are all the components we will need in order to do the rotation. Let me highlight them. So we got A here, and we got B here. We got T1, T2, T3, and T4, and of course also C. We got all the components over here. And as a quick reminder, just for our conceptual reminder over here. So we got A, B, and also C. And here we got T1, here we got T2, and we got T3, and then T4. And the rotation that we actually want to do is to rotate on the B. So B is actually going to become the new root over here. And we want to really maintain the in-order traversal. What comes before B will be T1A and also T2. What goes after B will be C, T3, and T4. Right, that's what we're going to have. So what I'm going to draw will be, so it's going to have a left child over here, A, and then T1, and then T2. Also, it's going to have a right child over here, C, and then T3, and T4. A very quick check on the in-order traversal. Before the rotation, we're going to have T1A, T2B, T3C, T4. And after the rotation, it's going to be T1A, T2B, T3C, T4. You can definitely review what I just said. So the order is really the same. And what this one will do is left rotate on the middle node B over here. That's what we're doing, right? It's a conceptual rehearsal about what we're going to do. And let's now try to see how we can rotate just this part over here, right? Let me just make it bigger, right? So the way I'm going to do it is like this, okay? I'll try to see. Okay, I gotta be very careful over here. So let me just move this part of the tree just away, just for now. Okay, just this part over here. Okay, let me see. Okay, just over here, just for now. And we know that the new root is actually going to be the B, right? So let's now put a new root back. So that will be the B. And the B is actually going to be this one over here. So I'm going to put B over here, right? And then I'm going to put T1A, T2, T1A, T2. So T1 is actually over here, which is external anyway. T1A and also T2, which is over here, that's also external, right? You can see both T1 and T2 are just external, which is okay. So let me just put the A over here. Let me put A over here. And then we got T1, and also we got T2, right? Okay, hopefully you're still following me. Everything is logical, okay? So B, we actually got here, left child, and also A, we got left child, and also we got right child over here. And don't forget, we still got the T1 and also T2 over here. I just lost the label, okay? And finally, what about the C part? The C part is going to be very straightforward. We can just keep this whole structure for C. That one there, I'm just going to move them from over here to over here, C. And then I'm going to put it over here. And I got T3 and also T4. Okay, let me erase other parts over here which we don't need anymore. And let me just update the balance for the tree quickly. What we will do is, let's now use maybe purple over here. T1 and T2, this just happen to be empty, so 0 and 0. T3, T4, similarly. Okay, what will be the height for A right now? A will be maximum of 0, which is 0 plus 1. Okay, 0, 0, and then maximum 0, and then plus 1. What about the heights for B? A and C over here, the heights maximum will be 1. 1 plus 1 will be 2. And then what about the heights for 78 over here? Maximum of 1 and 2 is 2. 2 plus 1 is going to be 3 rather than 4, right? You can see it's good news after the rotation. What about the balance for the heights for 44? Maximum of 2 and 3, which will be 3, plus 1, that's going to be 4. And it's now the new tree balanced. Indeed, it is. So we can now take a look over here. So balance or not. Indeed, after the left rotation on the B, it's now balanced. Especially, you can see what used to be the first point of unbalancing node, which is between 0 and 2. But now we don't have that anymore. You can see here, between the child nodes, 0 and 0, 0 and 0, 1 and 1, and also 1 and 2, and also 2 and 3. Everything is balanced. Right? So that's the first example about doing rotation. The reason that I really want to show you every step I did is so that you can actually practice this on a piece of paper. You might be required to show your steps in some assessment to show how you can do tree rotation.